Hey guys, welcome back. This is question number 6 of the 2026 AP Chemistry FRQ. A student performs a spectrophotometry experiment with a V2 plus solution and produces calibration curve as shown in figure 1 by measuring the absorbance of several solutions of known concentrations. So this is where we put on our Beer's law, right? Beer's law. It's actually, or in grad school called Beers-Lambert law, right? But it's called Beer's law. Poor Lambert. All right, so here we go. Part A. The student measures absorbance of 0.32 for V2 plus solution. The concentration of V2 plus ions in the solution is represented by the particle diagram in the circle in figure 2. In the figure 2, we draw the correct number of, oh, this is stupid, right? Look. So it measures the absorbance 0.32. That is 1, 2, 3, 4, 5. So it's going to 0.32 is right here, right? That's here, and that's at 0.08 molar, right? 0.08 molar. The concentration of V2 of the solution is represented by the diagram. So that is representing this figure 2. In figure 3, draw the correct number of ions to represent concentration of solution with an absorbance of 0.08. 0.08. What is that? That's going to be each one of these is 0.02, right? 2, 4, 5, 2, 4, 6, 8, 10, right? So it's 0.08 is going to be right here somewhere. So that lands you. They even put a dot. I mean, how silly. That's right here. So that's a concentration of 0.02 molar. So we went from figure 2 is 0.08 molar to figure 3, you want 0.02. So what is that? That's 25%, right? Or 1/4 or a quarter. All right. So we want to show quarter. How many we hit? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 here. So 8 divided by 4 is what? 2 dots. It's that easy. All right, so let's do it. Figure 3, gonna make 2 beautiful dots, and we're done. All right, so part A, 5A, 5A, C, figure 3, right? So that's part A. Part A, done. Let's check it off. All right, let's go to B. The student measures the absorbance of different V2 plus solution with an unknown molarity, but the absorbance is higher than 0.36, which is upper limit of the graph. So this is too concentrated. Solution then transfers 3 milliliters of this solution to a 25 milliliter volumetric flask, dilutes the mark on the flask with the distilled water, and measures the absorbance of the diluted solution. All right. The absorbance of the diluted solution is 0.22. Determine the molarity of V2 plus in the diluted solution. All right, let's go. This is B Roman numeral 1. All right, so did we just do this? Absorbance so let's determine the molarity of this dilute. All right, so part B. Wait, what? This is so stupid. Absorbance is 0.22. Wait, you're just reading it, right? This is like this. Elementary school kids could do this. 0.22 is right here, right? They even put a dot. Like what? That means it's this, right? Wait, could it be this? Yeah, it's this easy. That was really stupid. All right, so 5B, I, right? The molarity of the V2 plus at what? Is 0 point, what did we say it was? 0.55? Is that what we said? No, 0.05, right? Zero absorbance was 0.2, right? Or was it 0.22? A 0.22 is a little bit higher. So absorbance is like a hair higher, right? So it lands at like right there, which is like right over here. So it's not 0.05, it's actually just a schmear higher than that, right? 2E. No, oh no, actually it's even easier. Look at this. Each Y is zero point 0.2, right? 2.2 0.2, 0.22, 0.24, 0.26, 0.28, so 0.22 lands you actually right here, which is right in between 0.05 and 0.06. Therefore, it's 0.55, 0.055, right? 0.055. So therefore, 0.055 molar is your answer, right? All right, part two. Determine the molarity of the original undiluted solution. Show the work. All right. Well, um, this is very, it's just, you know, dilution equation, right? Right. What do we got going here? Well, let's go. What is our new dilution, right? Over here, our new concentration is 0.055 molar, right? And then let's go back to, and then how much of that do we have? This 0.055 molar was the fully diluted, right? So that's the that's this one, right? Right? So that was 0.25. I can't believe I put M2. It's V2, right? Milliliters, right? We good? Um, I'm sorry, 25.0. 25.0 milliliters, right? And then what else we know? We took originally 3.00 milliliters, and we don't know what the concentration is. That's it, right? So what is this? It's M1 V1 equals M2 V2. So therefore, V1 is equal to M2 V2 over M1, and then plug in everything in. No, what am I doing? We're solving for V1. We're solving for V1, which is M2 V2 over M1, right? No, wait. It's the same. Sorry. It's a long day. All right, so it's M1 is equal to V1, like that, right? So it's M1 V1 equals M2 V2, so move the V1 over to the other side. All right, so we got M2 0.055 molar times V2, which is 25.0 mils all over 3.00 mils. And what do we got? That gives me two sig figs, 0.46. Right? So what will we say? We say the molarity of what does that determine the molarity of the V2 plus is equal to 0.46 molar. Circle that, circle that. That's 5.2. And part C, the concentration is calculated is lower than the actual concentration of the undiluted solution. Student claims that the calculated concentration is too low because during the dilution step, the final level of the solution was higher than the mark on the volumetric flask. Do you agree or disagree? Just right answer. This is so easy. 5C, right? What do we know? Um, yes, I agree. Why? Um, the student overshot the mark, right? Overshooting, right? Um, in the volumetric flask means he, how do you know it's a he? I don't know, because he did something stupid. There's always a he, right? Means he added too much water. Water. Thus, um, it was over diluted and concentration value would be lower, right? Um, is the student claims that the calculated answer is too low because, yep, and that's the reason why. And that's it. We're done. Is that it? Get out. This was an easy question. Man, I hope you guys all got this one right. All right, I'll see you on the next one.